Welcome to another challenge problem. Our today's challenge problem is mid to end. It is a single linked list based problem. In this problem, you basically need to find the middle node and move that middle node towards the end. So it's a pretty simple problem, okay? And let's just look at an example. In this case, we have even number of nodes. So when you have even number of nodes, you basically pick the second node and bring it to the end. So here we would pick this node and bring it towards the end. So there are many ways to find the middle node. Like the very first thing is to find the middle node. So there are many ways. The one of the way would be like traverse the whole linked list, get the half length. Like if we have 6 nodes and we divide it by 2, that would be 3. So we again traverse until we reach 3. So this is one of the method, but this is not what is much efficient, as you are traversing 2 times. So here we will use a very famous algorithm, Claude-Warshall algorithm. So in this algorithm there are 2 pointers, and these 2 pointers play a major role. Like there is a slow pointer and there is a fast pointer. The explanation behind this is like assume that there are two person A and B, okay, and there is a racetrack. Okay, so assume that this is a racetrack, which would be our linked list. So here A and B, and the thing is that A run twice fast than B. Okay, the speed of A is twice as fast as B. So when the A will reach the finishing line, like when A will reach the ending, B will surely be at somewhere in the middle. Okay, so this is the approach. Now how do we do that in linked list? It's very simple. So here our the green line, basically this green line represents the slow pointer, and this red line represents the fast pointer. So the slow pointer takes 1 steps and the fast pointer takes 2 steps. So as soon as the fast pointer reaches the end, we stop. So we eventually get our uh, the middle node. Now let's look at how we can bring the connections so that this middle node comes to the end. So for that purpose, what we will do, we will have one more pointer which would be previous, like this. It would be our previous pointer. Now this previous pointer is basically the previous state of the slow pointer, and this our fast pointer would be somewhat here in this example after going towards the end. So as soon as we have this position, what we will be doing is we will be first of all cutting out this link. Okay, we will be cutting out this link, and we will connect this 9 towards the 11. So our 9 would be connected to 11. How we would do that? Previous dot next will point towards the slow dot next. So slow dot next is 11. So this is how we can do that. So in this way this link is now cut, and this is our new link. Okay, so this is our new link. Now we need to remove this link as well, and we need to set the end pointer link towards the 6. Okay, so we don't have any pointer pointing towards the end node. So for that purpose we will again run a loop. We will start from here. Okay, we will start from head. We will traverse our whole linked list, and till we reach an end. So here we will have another pointer, tail. This will basically point towards the ending node. Now what we will do is we will basically bring this tail pointer to point towards the slow. So how do we do that is tail dot next would become, assume that this is next. Okay, so tail dot, sorry for my handwriting, uh, the tail dot next will point towards the slow. Okay, and this is how it's gonna work. So tail dot next will point towards the slow, and the slow dot next will become none, as this would be our next ending node. So this would become none. So this is what the approach will look like. Let me just show you the code. It's a simple. We just need to implement a single function. So this is mid to end, and as I said earlier, that slow, head, and fast. At the initial state, there was no previous state of slow, so this would be pointing towards none. And now we start till the fast reaches the end, and the fast pointer moves two step. As you can see, that fast moves two steps and slow moves single step, and the previous is basically the previous state of slow. And in this way, we have our pointers set. So in this we are basically cutting out this link. As we have seen earlier, this link, we are cutting out this link, and this 9 is pointing towards the 11. So we are disconnecting the middle node, and this is for the edge case when there is a single node. And now let's traverse towards the end. We are reaching the end node, so we have named this pointer as tail, and this pointer basically points towards the ending node. And as soon as we have reached the ending node, what we are going to do is the slow dot next, that is the slow dot next will point towards the null, as this would be our last node. Okay, so this would be our last node, and this is our tail node, right? So this is our tail node, and our tail node is pointing towards the slow. So here what we, the same thing we have done, tail dot next is equals to slow, and after all this modification we are just simply returning the head of the linked list. Now let's just run this solution. As you can see, our test cases are passed, and let's just submit it. It's taking a little longer. Yeah, so our all the test cases are passed. uh, Thank you for watching.